Hi everyone, welcome SAS Programming 90 days. So today day 70. So we continue with the SAS Via session. So today we are doing. So first of all, we are today understanding this in the SAS Visual Analytics integration summary. Okay, so what is the integration summary? Is there? So integration summary in how the open source connect with the SAS. Okay, how does a SAS communicate with the open source language? So SAS can integrate with the open source technologies at any point of model lifecycle via APIs. Okay, so whenever we are building a model, so we are using the SWAT and DLPY. So what is SWAT? SWAT is a SAS scripting wrapper for analytics transfer. Okay, so this is a package for developed to allow to Python interface to access the SAS via platform. Okay, so this is a one of the scripting so for transferring the Python package interface into SAS via. Okay, and another is DLPY. So this is two famous models that we are using in the SAS. Okay, for transferring we're connecting with the SAS with the open source. Okay, SAS DLPY is a high level open source packages, for the Python APIs, and that are created for the SAS via 3.4 for deep learning and backend. Okay, and another is manage models. So for managing the models, we are using the SAS CTL and the PZMM, and deploying the models, we have the CAS. Okay, so cloud. So our SAS via is working on the CAS. Then mass we have containers and the uh, Kubernetes and the ESP. Okay, Kubernetes is open source. Okay, so this is also the open source. It's very easily we can connect with these open source with the SAS. Okay, so for the APIs, we are using these Kubernetes also. Okay, coming to the next, SAS Viya Analytics build a model. So how we are building the models? Okay, so in the last sessions we have done the SAS how to visualize with this SAS. Okay, so now we are building the models. Okay, how to build the models? SAS Model Studio is a visual interface in a SAS via allow you to build a model pipeline. Okay, pipeline are the processes flow or diagram that represent a sequence of analytics tasks and enable you to everything from a data pre-processing and building a multiple models to finding your best model, all within one pipeline. These analytical tasks are represented by as a individual nodes in a pipeline. Okay, so let's see how to build the models. Okay, then we will see all these how we are model studio will be work. Okay, so this is my SAS file, so I log in the SAS drive. Okay, okay, in the left hand side we have the analytical life cycle. We have done the explore and visual. Now today we are doing the build the models, how to build the models. Okay, so with this as some example for us, some templates also given by the SAS. Okay, so let's suppose some templates are there. Okay, interactive project, blank dashboard. Okay, so many uh, template are provided by the example provided by the SAS. Okay, and okay, now you if you want to see this template you can see, and also you want to create a new project, so you can. Okay, I click on the new project. Okay, and now they will be saying write any name. Okay, so my project, I given my name as a project as my project. Okay, and type of data mining or machine learning. So we have three options here: data mining and machine learning, forecasting or text analysis. Let's suppose I'm selecting as a forecasting. I want to do forecast. Okay, so so forecasting template is applied. Okay, and data So let's suppose I'm taking the example of DSK in product. Okay, so I'm taking this data, then okay, if you want to write any description, so you can write any description here, then save. Okay, so it's taking a minute for loading the data into the SAS build models. You can also see in the above, they automatically directed us in the SAS Model Studio and Model Studio build models. Okay. Okay, now you can see here we have our data here. Okay, so now they are saying you must to assign a dependent variable in your pipeline. Okay, so we have to write here some we have to select the some default one. Okay. Okay, so here we have the five columns in my data. Okay, so five variables are there. So first is date. Date is by default the time they automatically selected. Next is the discount. For discount, this is my independent variable because that is a different because this is the independent variable. It's not depend on the another values. Okay, so I selected as a independent dependent discount. Okay, and the average of value. Okay, so average hierarchy aggregation is average value and average of value here, and missing value is interpretations. Okay, correct, uses the model. Yes, okay, let's leave it the other things default. Okay, then is revenue. So revenue is my dependent. Okay, so I selected as the dependent here. Okay, so I selected as a dependent. Next, now they are saying hierarchy is sum of values, and the time interval is a sum of value and interpretation for the missings. Okay, correct, good. Okay, now these things are done. Okay, next go for the pipeline one. Okay, so in the pipeline, if you see, automatically they doing the forecasting. Okay, we didn't done anything, auto forecasting is done. Okay, so if you right click here, if you so how we are creating this pipeline. Okay, so we need to go to the pipeline, then we are adding the pipeline like this, add to child node and forecasting, auto forecasting. Let's delete this. Okay, now let's suppose we have data. So if you select the data, then your data will be show like this one. So data is here. Okay, now you need to right click, then add a child node. Okay, else if you click here, so you can see all the forecasting model and the all the things are here in the left hand side. Okay, so if you click here, so you can add it from the here, or else if you want to add from the here, so you can add auto forecasting. So we are clicking on the auto forecasting, so everything will be happen automatically. Okay, they will be automatically predict the everything. Okay, it's with the auto forecasting, you can see here the steps automatically fit the best model and generate the forecast from the selected model family. So automatically everything they will be do. Okay, comparison in the second we have the model comparison. In the model comparison we have done, then also the output. So if you created the pipeline, then you have to click on the run pipeline. If you click on the run pipeline, so then your this pipeline will be executed. It's taking a time, so you can see here the time is showing here. Now this is executing. Okay, so it's running. So if any problem is there, if any data is missing, so they will be also see that one. Okay, let's leave it as they automatically running. So now the data process is run. Okay, now it's showing status as successful. If any interruption is there, if data is missing or any problem is there, so they will be show the errors also. So in my data is error. Okay, Okay, model comparison is going on. Okay, now pipeline is completed, so also we see the this one. Okay, now this is my pipeline. Okay, now pipeline comparison. Okay, so in the pipeline comparison they will be showing the all the things. Okay, this comparison they will be showing number of series is 1, number of failure 0, number of forecast equal to 0. Okay, so that is done override. So in the overrides they will be show you the details. Okay, they will be show the time aggregation, the overrides plot. Okay, so now you can see here this they showing the some forecasting of your data. Okay, so what is a historical data? Historical data is this is your historical data, and what is a final forecast? So final forecast is this. Okay, this line is a final forecast. Statical forecast is your this is your statical forecast in this line, and next is your statical confidence limit. Okay, so this line is a statical forecast limit, and you can also see this in the numbers also. Okay, so this is a final forecast, lower confidence. Okay, upper confidence. Okay, so this is showing according to the date, Sunday April 19 to 15, then we have Sunday 26 April to 15. Okay, 2015 that is showing. Okay, next is the override management. In the override management it's taking a time to. Okay, override display is not available. Okay, let's go to the insights. Insights, we will see about the details of everything. Okay, the my project contains one time series. Okay, one time series is there. The dependent variable is revenue. Across a one pipeline, the champion modeling strategy is auto forecasting, does not use any events, and weighted mean absolute percent error of winning strategy is 3.221. Okay, and created by auto forecasting pipeline. Okay, date, and this is selection last modified. Okay, so everything, every details are here. If you want to add any comments here, any description for the future, so you can write. Okay, this is a map distribution, and this is about the execution summary. So if any failure, if anything problem is there, is seasonal forecast data. So every details, every single variable details, everything is here. Okay, so this is about data definition. My project was created by this data set. Independent variable is revenue. Independent variable affected the forecast. Okay, so number of independent variable, one. Independent variable is the time variable is date. Okay, so this is how we are creating the pipeline, how we are building the model with the. Okay, so how we are creating the pipeline here. Okay, this is example of the forecasting. Okay, so how we are doing with the forecasting. Okay, next we will go for the how we are doing the model. Okay, so this is I have done about the forecasting. So also we have many project are there. Okay, let's go for the new project. Okay, in the new project now I'm taking the example for the new dashboard. Okay, so now I'm taking the example of data mining and machine learning. Okay, so if any template is there, no template is available. Okay, data, so you can select any data here. Let's suppose I'm taking the bank customers data. Okay, then okay. Okay, if you want to write any description, so you can. So I'm not writing anything. Okay, one thing I'm missing here. Okay. Okay, so let's go back to for the new project again. Okay, new dashboard. Okay, and then data is my bank customers data. If you want to export from the other data source, you can, and you can import from the local files, or if you have some map drive, some map location, so you can. Okay. Okay, so in the advanced, if you click in the advanced, so now you can see here we have the first is advisory option, maximum class level, and the maximum percentage of missing is 50. Okay, then we have the that partition data. Okay, so partition data is showing the for training and validation for data. So I'm not sending for the test data as a 10. I'm giving the 70 for the training and 30 for the validation and 0 for the test. Okay, so I don't want to waste my data, so I want all my data in my queue. Okay, if I'm not sending for the test. Okay, node configuration is okay. So if you want to prepare it as a Python configuration code, so you can click here, so that Python preparation code also will be there. Okay, next I click on the save. Okay, it's new dashboard is also there, new dashboard one. Okay, so it's taking a time for loading. So here we have the data pipeline comparison, and the insight. So all the information that will be displayed in the here. Okay, in the data we will see, we can see our data. Okay, so okay, so this is my data. Okay, now in the above you can see here one message is here, you must assign a variable with the role target in order of run the pipeline. Okay, so you have to select any target. Okay, so if you're not selecting the target, they can't proceed further. Okay, so let's suppose I'm selecting my income as a target, so I selected with the checkbox. Then role, in the role I put it as a target. Okay, so this is my target. Now everything will be done. Now I'm going into the, so if you want anything on your data, okay, if you want to do anything, let's suppose I want to see missing values. Okay, so in the SAS Viya you can perform every on every variable you can perform different operation. Let's suppose I selected the city. For the city I want to do something. Let's suppose I want to segment it, I want to target it, I want to predict. Okay, so in the SAS Viya we have the freedom for doing the things on different columns. Okay, uh, so I want to format ascending, I want to format descending. Okay, I want to some see the missing values on from the city, I want to see for the address only. Okay, so we can perform single on single column, we can perform single operation. Okay, it's not applying for the all. If you want apply on a single, you can. Okay, let's go for the pipeline. Okay, so you can see here in the pipeline we have the data. Okay, so now these options are here. Okay, data mining processes. So we have four types of nodes are here. This is this called the nodes. Okay, these are the all the nodes. We have data mining, pre-processing, supervised learning, post processing, and the miscellaneous. So I click on the data mining pre-processing. Okay, so now you in the data mining pre-processing, what we have. So we have in the data mining processing we are adding here data mining processing as a let's suppose imputation. Okay, so what is a imputation? We will see here also. You can see if you click here, so automatically they give the description. Imputes are the missing value for a class and interval inputs using a specified method. okay, and the missing percentage is cut off 50. Okay, maximum that will be a cut off 50. Also you can see here I write it the definition for the imputation. So okay, so imputation is an important aspect of data preprocessing that has a potential to make or break your model. The goal of imputation is to replace the missing value with the values that are close to what the missing value might have been. Okay, when considering the imputation, you have to main two tasks: try to identify the missings, the data mechanisms, okay, and determine which methods of imputation to use. Okay, and simply write it here: missing data. One reason for imputation may be used is that many machine learning models cannot use a missing values and only do complete case analysis, meaning that any observation with the missing value will be excluded. Okay, so imputation I have done here. Okay, after the imputation, what I'm doing, I'm selecting, let's suppose I'm doing now supervised learning. With the supervised learning, so I will create what is a supervised learning, what is a unsupervised learning. Okay, supervised learning, I'm creating the one linear regression. Okay, so I selected the linear regression. Now you can see here we have the linear regression, data imputation, then linear regression, and the model comparison. So every this color is every color is different. Okay, so let's run the pipeline. Okay, while it's taking a time. Okay, and also this is the node we have. Okay, next we have the anomaly detection. What is anomaly detection mode? Is identify and exclude the anomaly using the support vector data description and SFDD formulation outline to determine the possible. So identify and exclude the anomalies observation using the support vector data description. Also we have filtering in the data mining process. Okay, so this is all the types of data mining: manage variables, replacement, transformation, that is available into the data transformation. Sorry, so data modification, sorry, in the data modification we have anomaly detection, filtering, imputation, manage variables, replacement, text mining, and the transformation. Okay, so every block, so you can see here we have different coloring in the blocks. Okay, so what is that color block? So for orange blocks are the data mining and the purple blocks are the models. Okay, this is the model. Linear regression is a model. Okay, and this is the data and this is a model comparison, and this is my data mining process. Okay, it's taking a time for creating the model. Okay, so linear regression is done. Okay, in the last step we have the model comparison. Okay, now this is the completed. Okay, let's go for the pipeline comparison first. Okay, in the pipeline comparison we will see about the okay average ASC we have here. Okay, sum of frequency is 145. Now you can see here we have the effect interspect and the interspect parameters. Values are here: estimate, absolute, and the standard. Okay, this is a parameter inspect, and the this is all your predictions are there. Node score code, path score code. Okay, this is all the code. Okay, this is the predicted mean. Okay, what is a predicted mean there? Okay, and this is the data role is validate and the train. Okay, this is your SAS code for the training one. Automatically they created the all the SAS code you can see here in the last. Okay, so what they write it, what how they executed everything. Okay, okay, in the last we have the these all the SAS system about the data. Okay, so that is available in the logs in the SAS Studio. You can see here automatically about the all the comparisons of the data. Next we are going for the insights. What is the insights? Insights is here is related to the okay your okay, this is about my project. Overall average is there. The champion model for this project is a linear regression. We use a linear regression model. The model was chosen for the based on the average of ASE. Validate the partition. The five most factors are imputed, gender, and the others. Okay, assessment of the products and the actual predicted values are there. Okay, so this is how we are creating the pipelines, how we are creating the data models. So today we have done the basics one. Now we will go for the more further advance in the models. Okay, so we will see the how we are data mining process and the other models. Okay, decision tree and many models are there. Okay, so we will continue tomorrow in this session. Thank you guys.